What we start off with in this unit is a review of our whole unit of transformations with some new graphs. In transformations, we did stretches, compressions, translations based on our parent graph. What we do in the beginning of 5.1 and 5.2 is we get introduced to new parent graphs. Here is our first new parent graph, y equals 2 to the x. It's an exponential graph. How would we find it if we didn't know? We could draw a table of values. So very quickly, if I plug in negative 3, I get 1/8, 1/4, 1/2. Anything to the 0 would be 1, 2 to the 1 would be 2, 4, and 8. If I label those points, I have 0, 1, 1, 2, 2, 4, 3, 8, half, 1/4, 1/8. That's what the points look like. So just the ones that I graphed, if I connect those ones, they look like this. And this graph is going to continue. So I can put an arrowhead here. And an interesting thing is going to happen as we go to the left. It's never going to go negative. Does that make sense? Because if I put a very big negative number here, like 2 to the negative 1,000, your negative exponent rule says that's 1 over 2 to the 1,000. That's still a positive number. And is really close to, if you divide something by a huge number, you get really close to 0. What do we draw on graphs when we get really close to something? These exponential graphs are going to have an asymptote at y equals 0. So there's a couple of reasons this wasn't done in the transformations unit. You had enough graphs already to deal with in the transformations unit. It's kind of nice that we do it again here because you get to review your first unit. So it helps you relearn that first unit because you're going to need to know that for your exam. And the other thing about about exponential graphs is there's not just 2 to the x. There's 3 to the x, 4 to the x, 5 to the x, 6 to the x. We have to be able to graph all of them. So we're going to graph another one right now. Just pick a different base. Let's say we choose 5. And we graph 5 to the x. We're not going to need to do a table of values, but we're going to find out that for any exponential graph, there are 2 that are very important to do. First of all, plugging in 0, doesn't matter what the base is, you will always have 0, 1. So that's why I labeled 0, 1. And we're also going to label 1, something. And I hope it makes sense that when you plug in 1 for x, you will just get the base. Because 5 to the 1 is just going to be 5, 2 to the 1 was 2. So you get 1, 5. All of our exponential graphs, or parent exponential graphs, will have an asymptote at y equals 0. And once you have those 2 points, well, they're going to be connected like this. It's sort of like, oh, how would I continue to graph it so that it goes towards the asymptote? This is the shape of y equals 5 to the x. So with this knowledge of these 2 key points, you now can graph any exponential, just plain exponential graph quickly. The one that they have on the next page is 1/2 to the x. So we're going to use the quick method to graph this. and we'll fill in the table of values after. The quick method would say, well, if I plug in 0, I'm going to get 1. So every exponential graph has 0, 1. And if I plug in 1, my base is a half. So I'm going to get 1, 1/2. And every exponential graph has an asymptote at y equals 0. This one's a little bit different because if I connect the 2 points, it's like, oh, it looks like this time it's going towards the asymptote this way. And so it would have to go up this way. So some exponential graphs are increasing. This is an exponential graph that's decreasing. Had we done the table of values, we already did this one as 1, this one was 1/2, this will be 1/4 and 1/8, this will be 2, 4, and 8. And what I want you to notice between the 1/2 x graph and the 2 to the x graph that we graphed first is, can you see that they're just flips of each other? A reflection over the line, the y-axis. If we think back to our transformations, if you flip something over your y-axis, that's a horizontal reflection. Horizontal reflections result with a negative before the x. So the question is, why is y equals 2 to the negative x the same as y equals 1/2 to the x? So we're going to see if we can do some algebra to prove that those two are the same. And I'm going to start off, it's kind of like a proof. I'm going to start off with y equals 2 to the negative x. On this side, I'm going to write y equals 1/2 to the x. I can make it the same format as a proof. Have a left-hand side and a right-hand side. Are you okay that I could use my exponent rules, and instead of having a negative x, I could have a -1 inside multiplied by an x on the outside? That would be the same thing. Because you have an exponent rule that if you have a power to a power, you multiply your exponents. Then if I have that 2 to the -1, like, oh, but that's my negative exponent rule, I could write that as 1 over 2 to the +1, which boy, I really made this like a proof. But I'm just showing that those two are the same. So if you wanted to graph a 1/2 of the x, it's the same as taking your 2 to the x graph and causing a horizontal reflection.